In this video, we're going to take a look at complex numbers, and specifically multiplying and dividing complex numbers. And the key when we're working with multiplying and dividing complex numbers is that we need to remember that we've got this thing, this imaginary number that we've defined as the square root of -1. And when we take that number and we square both sides, we can find out that I squared is just -1. Yeah. So I squared is -1. That's the key, all right? Because that's going to show up often. So let's check some problems out. So first we got a problem here where we're multiplying a couple binomials together. Now, if you were to see this problem and not know that it was a complex number, you would just distribute this out or FOIL it out. And that's exactly what we're going to do. So let's take our -3 times our -4. That's -12. -3 times -6i. That's going to be a positive 18i. We've got a 8i here, and then multiplying these guys up, we got a -12 I times I squared. Now what we just said though is that I squared means -1, the square root of -1 times the square root of -1, so I squared is -1. So we can rewrite that. Let's go ahead and put these two together. They're both i's, so we're combining like terms. And this is -12 times -1, because that I squared is -1. Well, -12 times -1 is going to give us a positive 12. And what do you know? These cancel. Not always going to cancel, but in this case they do. And we're left with a purely imaginary number, 26i. Well, what if we have 3 plus i and 3 minus i? Well, let's distribute that out. We get 3 times 3 is 9. We get 3 times -2. That's going to be -6i. And a positive 6i. And a -4i squared. So these here cancel out. And this is -4 times -1, because I squared is -1, so this is -4 times -1, which is a positive 4. And we end up with 13. Now, it's a special case we're going to come back and look at here in a minute. We'll generalize that. But before we do, let's look at a problem down here. We've got 2 negative square roots, and it seems like we should be able to just multiply those and get the square root of square root of third, positive 35. Because -5 times -7 is 35. But we got to do a little bit more than that. We can't just jump like that. Let's see there. So what we want to do is we want to rewrite this as the square root of -1 times the square root of 5 times the square root of -1 times the square root of 7. And in this case, we have I times I. Those two are i's there. And now let's multiply that together, and we get the square root of 35. So in the end, we get I squared times the square root of 35, which is going to give us -1 times the square root of 35. Negative square root of 35. Okay? So watch out for that case. A little different thing there. Now let's generalize this thing we saw just a moment ago with the 2 and the 3's. So we have a times a, that's a squared, a minus bi minus abi plus abi and minus b squared I squared. These two cancel out, and you might expect that because this is a difference of 2 squares in the end. And so here we have -b squared times -1, which is going to be a squared plus b squared. So we actually get, because of the I, we get not the difference of 2 squares, we get the sum of 2 squares. So this is our complex conjugate product rule. So these are called conjugates when we have a binomial that has 2 terms being added, and they almost exactly the same binomial, but the sign is different. That's called a conjugate. So the conjugate of a plus bi is a minus bi. And so when we multiply those together, we always get a squared plus b squared. That's a useful little shortcut to know. Notice that we have no i's over here. So when we multiply these two, the i's go away. It's not imaginary anymore. It's purely a real number. Well, now let's do some dividing, and that's going to be useful, what we just had, that complex conjugate rule. Here we have 6 plus 2i divided by 4 minus 3i. And remember, fraction means divide. We want to get rid of the i's down here. We want to make the i's disappear. So to do that, what we're going to do is we're going to multiply by the conjugate. 4 plus 3i. 4 plus 3i. Now let's keep in mind that, I'll copy it down here, a plus bi times a minus bi. We just proved that that's going to be a squared plus the b squared. So what that means is that on the bottom here, we got to put some parentheses here. When we multiply this out, we're going to get a, our a is 4, so it's going to be 4 squared, and then we're going to have plus, and we'll end up with 3 squared. You can multiply it out, and you'll see that it gets that same thing. So we end up with 16 plus 9. And that's nice because there's no i's on the bottom anymore. Well, let's go ahead and multiply the top out here. And we get 4 times 6, 24. We get 6 times 3i, that's 18i. In the middle, we've got 2 times 4i, that's 8i. And then at the end, we got 6i squared. Okay, so that's going to be 24. In the middle, 18i plus 8i, that's going to give us 26i. And this i squared is going to be negative 1, so this is going to be negative 1 times 6, which is minus 6. All over the 16 plus the 9 is going to give us a 25. Clean it up a little bit more. We get 24 minus 6 on top. That's 18. And what we're going to do here is we're going to divide both of these by 25. Because dividing by 25, this 25 affects both all these terms above. Okay? So we're going to break that leftover up like that. And we're almost done. We'll just kind of pull this I down. 18 25ths cannot be simplified. So it's 18 25ths. That's the real part. Plus 26 25ths I. So this is a complex number. We have a real part and imaginary part. All right. And last one here. What if we don't have a binomial? Okay. Well, we can multiply by the conjugate here. The conjugate, this is like 0 plus 5i. And so the conjugate would be 0 minus 5i. But you can really get away with just multiplying by 5i, or even easier here, we can just multiply by I. In the end, you'll get the same thing. Now, if you want to be consistent, multiply by the conjugate, negative 5i. Okay? Well, let's be consistent here. All right? Let's multiply by negative 5i. And we'll see in the end that it comes out to be the same if we just multiply by I. So on the bottom we get negative 25i squared. On the top we're going to distribute here. We get negative 15i squared and plus 20i. 20i, negative 5 times negative 4. Okay. Well, this negative 15i squared, well, that I squared is negative 1 times negative 15. That's just positive 15 plus 20i. And the bottom, this is negative 1 times negative 25. And that's going to be positive 25. And now we're going to see all those 5s cancel out. We're going to break this up. 15 over 25 plus 20 over 25. 20i over 25. This will simplify. There goes those 5s that we multiplied because we didn't necessarily need to. 3/5. And 20/25 would be 4/5. And we'll just pull the I out in front because it's the same whether it's out in front or out to the side or up top, because this is just multiplying. And there's our answer. This is written as a complex number. It has a real part. It has an imaginary part. Okay, so when we're dividing, again, multiply by the conjugate of the bottom, and that's kind of like rationalizing the denominator. Very similar process there. And in the end, write your expression in the form a plus bi. Some number here plus some real number times I. Okay, there you have it. Good luck.